I'm Greg Glaros, founder and CEO of SYNEXXUS. We started 10 years ago. And what I want to really just take you on here is a journey of game-changing efforts. Some of the things that we do and we've done for the past 10 years was actually connecting all the things that you just saw. The robots, the radios, the devices, the weapon systems, and brought effectively those products together within an enclosed envelope so soldiers and Marines and sailors had access to that information at their fingertips. Factually, what we wanted to do was, from my heritage, is bring the cockpit into everybody's life. And why that was important, it wasn't that I wanted everybody to wear a scarf from that standpoint, let their hair down and go fast. The genuine benefit of doing that is it brought together your whole environment within yourself, allowed you to control every element in your life at that moment for survival and for protection. And the fact remains is in a cockpit, all the investments that we've made over the years, in the decades, to ensure that one single individual can control such a high-performance aircraft is often doesn't translate financially into other sectors. But factually for us, what we've done is we took that same technology and we placed it into vehicles, so that the soldier, which is now used today in your more expensive cars and infotainment, that had the origin, frankly, from devices just like this that we've made. And we manufacture right here in the United States. We take those ARM processors that are in your phones, and frankly, we bring those forward in an industrial context and allow everything to connect through them to create edge computing or cloud servers right locally for you. Why is that important? Again, so you can control your own environment. With the issues of cybersecurity and the hacking that goes on today, that was not unknown to us. The military has always been concerned about intrusion into their lives, and factually what we've done is brought that down to the level that was usable in the vehicles. So the glass cockpits that we've created in there allowed our soldiers to survive in a fashion they couldn't before because they didn't go into the threat because they were aware of it. Where have we gone from there? We've taken this the same technology that was in our vehicles, and now we've put them into the power transformers. Your energy today, locally, right now, in the past, had no intelligence to it. It had oil in there. They'd send a technician out to the field in a remote area. They would take an oil sample of that, send it to a laboratory. 3 months later, they'd understand what the system was doing. What we've done is taken those same devices on the edge computing and did the monitoring, the metering, the connectivity that was required for us to access that information anywhere and understand the performance of that system, more importantly, provide the security. Believe it or not, every single day, your transformers are being not hacked into, but physically attacked. Copper theft, pot shots from rifles, chain falls hooked around to them so that they can be pulled off their foundation to destroy them every single day. Everyone worries about a cybersecurity threat of hacking into those things. There's a physical security, and we have no notion and no understanding of how that's happening until a station goes down. What our systems are doing, because we've designed them here in the United States, in fact, right here in Arlington across the river, the hardware, the firmware, the software, the enclosures, the manufacturing, is you can't hack into our systems. And I would challenge anyone who has that background to potentially take a shot at it, because we have a closed enclave that allows our customers to participate in the industrial Internet of Things, of which things are not being manufactured for. So if you want an opening from a business perspective, we're not really designing anything for the industrial sector to help us to connect in a way we should. The commercialization of the Internet of Things is very powerful, but it's not happening on the industrial side to give us the maximal connection we need. The other things we've done is taken that same edge computing, and all the lights in Arlington County in particular, in New York City, are controlled through our gateways, so that it doesn't allow just the switching out of LED lights so that you can reduce your power consumption by 30 to 40%, but that you can maximally manage that power and understand the movement of people within that network. And one gateway that we have controls over 10,000 lights simultaneously in doing that. Again, you can only get there by local computing, local servers, and edge computing on the devices itself. And we're able to get there from that standpoint by a company that's doing all the vertical integration of those with American citizens, predominantly veterans, that are working and making everything work from the engineering, mechanical design to the software. The last item I'll show you what we're doing is in an industrial sector, or in the commercial sector, it is required by fire law that every fire extinguisher, every 75 feet, should be monitored. The American Disability Act has moved that forward and says you can't have any intrusions or any kind of barricade in front of it so that you can gain access to fire suppression or fire detection systems. So we're designing those systems that go in every one of those gangways so that when anyone walks by it, or the fire extinguisher has been used, or the pressures are low on that, we can provide that information back to the customer for both inspection to be in compliance with the fire law, but more importantly, so that we can understand the behavior of consumer actions within the walkways of their stores. Again, it has the same architectural principles that we've applied here. All of you have seen charts like this in so-called the growth of the industrial Internet of Things, but one of the things you probably haven't done was know where the origin of this came from, frankly, from a man named Ron Close, who won the Nobel Prize, talking about that statement did right there. So the reason in this fast and explosive growth in our technology and the innovation that exists is because of the information that's able to be shared across the board in a fashion, in a manner that we couldn't conceive of before. It changes us organizationally, it changes how we communicate, and factually, it changes us how we advance our cause. And that's why we're seeing an explosion in these things. All right, I'm going to shock you now. Talk about game changing. The roadmap that I took you from my time as a fighter pilot, taking the cockpit into the vehicles, into the commercial sector for power transformers, and directly into your homes of fire protection and safety. Frankly, a lot of this origin happened here. These were game changers in those days, and you should take heed of it. It wasn't the fact that the dreadnought, the battleships, were created in a year and a day, fundamentally changed the world of how we engage between forces. But it also precipitated the advancement of wireless communication. It also precipitated the need for satellites for weather communication, so we understood weather patterns, because if you look at the history of the United States Navy, half of all ships lost at sea was due to weather, not combat. So the United States Navy made the investments for weather satellites, of which we all share, and frankly, John Deere and Caterpillar in their farming equipment are using to help manage our farms for agriculture. This was game-changing in its day, and it opened up the sea lane so we can do all global trade that we're all participating in. Ballistic missile development. This was done in a course of 4 years that fundamentally changed the way of the triad of how we protected our nation and how we participated. What did it game change? Rocket propulsion, satellite launching of those vehicles, satellite communications, global communications so that we can coordinate attacks in the event that all infrastructure goes down. Fundamentally game-changing for it, but it happened in a short period of 4 years. Panzer development. This is the thing, the scourge that changed the face of Europe, categorically, in a manner that none of us can conceive. And why I'm taking you through this short history lesson of where we are today, where we're going, the truth be told is many of these things didn't happen in our border that changed us. What is going to happen today that will fundamentally change our lives forever, as it did so far for the last generations? The last one is the U-boat development. There were only 57 of these boats that were the scourge of the Atlantic and stopped all trade. But what did it lead to the development of? Encryption. The birth of cybersecurity and the fact of how to hack into these things that stopped the proliferation of stopping free trade and the movement of goods and the protection of another continent. So that history lesson I'd like you to take home with what's game-changing and what you think is game-changing technologically is also organizationally. We've talked about the policies that are in place, but it impacts our lives in living or dying, not just paying your mortgage and buying a fancy car. Okay? So thanks very much for the time. We'll get you back on schedule.